these are the 12 parent functions of precalculus. And in addition to these 12, there are another 3 that I've added just because of convenience. They tell us something. And the reason we have all these functions in precalculus is because altogether they help us model almost anything we can think of. Either transformations of these functions themselves, or ones that are related to them, or combinations. And we're going to get into composition functions. So that's our toolbox as far as what we need to go. No, you could, but I'm going to go on here. We're going to check all these functions for these 5 things: odd or even, domain and range, vertical and horizontal asymptotes, boundedness, and end behavior. Now, specifically in this class, we've already talked a lot about domain and range, and we've talked about some about vertical and horizontal asymptotes, but these other things are not going to be as familiar to you. So we're going to examine all these functions with these traits. The first function is called the identity function, sometimes called the linear parent function, and this is f of x equals x to what power? To the first power. All right? So we're going to ask the question, first of all, evaluate, is this function going to be odd or even? The function is going to be odd, and I'm going to briefly explain to you why. Yes? Okay. What happens is that if you can rotate, if you have rotational symmetry, in this case, if you rotate this 180 degrees, do you see that you have a reflection upon itself, or comes back upon itself? That is a characteristic of an odd function. So this function is odd. Also, if we can write this as x to the power of something, is 1 an odd number or even number? It's odd. So if we can write it, not all the parent functions we can write as x to the power of something, but if we can do that and that number is an even number, well then that's an even function. If it's an odd number, like in this case, odd. Next, we're going to evaluate this function in terms of domain and range. What is our domain of this function? Yes, you're exactly right. And we're going to write that down in interval notation here. Negative infinity, comma infinity, enclosed within parentheses, which we call an open interval. What is going to be our range of this function? Thank you, Mr. Quesada. All right. So we understand all this. Next thing we're going to look for is vertical asymptotes, which I'm going to go ahead and abbreviate as VA, and horizontal asymptotes. Do we have a horizontal asymptote or vertical asymptote for this function?
No.
No, we do not. And probably a lot of these categories will be no as the answers. Okay, if we go to, we're going to check out boundedness. Now, for boundedness, what we do is we're checking for boundedness above and below. And what gives boundedness away more than anything else is the range of a function. In this case, what is our range? Greater than negative infinity to less than infinity. Is there a boundary here where the function does not stop, either high or low? So we say this function has none in terms of boundedness. Next thing we're going to look at is something called end behavior. And we're going to introduce with this a notation. Behavior. It'd be nice to be able to spell. Okay. All right. End behavior. Now, what is end behavior? Anybody have any idea what end behavior is? And no, it's not how you act like just before you die. That's not end behavior. Okay, she laughed. She actually smiled, okay? She didn't actually laugh, but she smiled, okay? She got the joke. Yeah, what happens is we look at the end of the function. As we write it as a limit, Hey, Monica, I'm proud of you today, Monica, for laughing at my joke.
She get extra points for that because if she
No, he was. No, she was just gently amused. Okay, as x goes towards infinity, what does y go toward?
Infinity.
Yeah, infinity. So we call this end behavior, and this limit notation should be new to you, right? You haven't seen this before, right? Now, most of the time when we evaluate functions, do we go from left to right or left to right to left? We go left to right. But this is the exception here. When we go evaluate toward negative infinity, we can go towards limit as x approaches negative infinity of f of x. As x goes lower and lower, where does this function start? You're looking for where the thing starts. Where's the thing coming from? What is down here?
Negative infinity.
Yeah, negative infinity. So in this case, would be our end behavior notation. All right? Okay, we're going to be going through these pretty quickly. Next, the squared function. This is x to what power? Second, right? So is this function odd or even?
Even.
Yeah, the function is even because we can write x to the power of something, but more significantly, does the graph of this function have symmetry about the y-axis? Yeah, it does. So that's another, that will tell you it's even. There's an algebraic definition as well. What is our domain of this guy? Our domain is going to be, as we noticed for the linear one, all real numbers. And our range? Greater than 0? Almost. We almost got that right. Greater than or equal to 0. So in bracket 0. Instead of greater than 0 would be parentheses. We're going to get into one that has that situation. And do we have a vertical asymptote? No. Do we have a horizontal asymptote? No. Okay, next we're going to check for boundedness. I'm just going to abbreviate boundedness, call it bounded. Does this function have boundedness? Boundedness will be a lower or upper boundary to the function. If we look at the range, that will give us a clue a lot of times. Does this function have boundedness? Where is the boundary located? Yeah, boundary is located down here, right? If I draw this little horizontal line segment, so we say this is bounded below. Yes? No. If you have a range that extends from negative infinity here toward to infinity, there will not be boundedness in that instance. Okay? That's a good question. All right. Next, we're going to talk about end behavior. And our end behavior, we write in our limit notation. Limit as x approaches infinity of f of x is. We're going x toward infinity. What does y do? To, yeah, infinity. And limit, we go to the left now. Limit as x approaches negative infinity of f of x is.
So do you just do that based on the range?
For boundedness, yes.
No. For the unit.
No, it's not range, really. Well, for the end of the range, yeah. That's what you're saying, yeah. You can also, yeah, that's a good idea. Sometimes you can get your, well, not always. Not always. You'll see exceptions, but in this case, it would apply. So as we go toward negative infinity, what is the function going toward? We go toward negative infinity, right? What does y go toward? Which is toward what? Toward what? What do we put here? Now, where's negative infinity is down this way, right?
Zero.
And so we put positive infinity. Okay? It's a little warm in here. I appreciate your patience. Okay, cubing function. Odd or even? Yeah. Okay. What lets you know this thing is odd? Okay, to the third power, but more significantly, what does this thing have? Rotational symmetry. See that? Rotational symmetry about the origin. Okay, what is our domain of this thing? Okay, you guys wore me down. I'm just going to do this thing here, okay? You wore me out. I'm trying. You got to save some time. Okay, range is what? Okay, and what is going to be our horizontal asymptote? Our vertical asymptote? We have no. What is going to be our horizontal asymptote? None. Do we have boundedness? No, we don't, because range is negative infinity, positive infinity, so we have none. Yes. Yeah, what I'll do is, when we get to a function that has one, I'm going to stop and explain that. But yeah, I appreciate the question. That is a very good question. Okay, the limit as x approaches infinity of f of x is infinity. Limit as x approaches negative infinity of f of x is negative infinity. All right? Of what? This is end behavior. This is where the function starts from. This is where the function ends up as you go to the right.
So when you put the star on the bottom, does it matter?
What do you mean?
Because you said this is where it starts from.
The function starts from negative infinity. Okay? It comes all the way up from negative infinity, starts going toward positive infinity as the function goes towards infinity. Comes from negative infinity, crosses 0, 0, goes up toward infinity. Okay? So it's kind of where the function starts, where the function finishes. Next, reciprocal function. F of x equals 1 over x. Okay, can we rewrite this function as a power of x? Can we rewrite this as x to the power of what?
What do they have? 25.
No, that's a different function. 1 over x is x to the power of what?
Okay.
Somebody said it.
Okay.
Okay, Shelley said it, but somebody else said it before Shelley. Some girl said -1 before Shelley.
I said I like
Actually,
We said, okay, so Shelley did it both times. All right. So is this going to be odd or even? Yeah, this would be odd. Odd. Okay, good. And again, this has rotational symmetry. You see if we rotate this thing 180 degrees, it'll just come upon itself. Good. Next, domain.
doesn't touch zero.
Okay, does not touch 0, right? So how many pieces are we broken up into here? Yeah, we could. We could look at a number line, but we won't. What goes here?
Negative
infinity.
Zero.
And then what's that other?
infinity.
0 and positive infinity.
So that's our domain. All right? And we're going to go to range now. Yeah, the 0 comes right here. The function will not touch because we cannot divide by what? 0, right? So the function is undefined for x equals 0. What are your questions?
not put over and over, not be
Yeah, that's possible. You can do that. What is our range going to be?
Negative infinity to 0.
Well, in this case, it's going to be the same. Now, Kiera asked a good question a little while ago, and we're going to answer that question right now. Okay, what is our vertical asymptote?
0.
What 0? What's our vertical asymptote equation? X equals 0. Very good. And what's our horizontal asymptote?
Right.
Y equals 0. Okay. Okay, Kiera, well, here's where we go. If you have a vertical asymptote, if when you approach from one side, in this case, if we approach 0 from the left, what does the value of the function go up toward? As we approach 0, right? If we have 1 over x, if we divide 1 by 1, what do we get? 1. If we divide 1 by 0.1, what do we get?
2.
10. If we divide 1 by 0.01, what do we get? 100. If we divide by 0.001, what do we get? 1,000. Okay? So as we divide by numbers closer to 0, what is this function getting closer to? Infinity. And so here, as we go to 0, as we approach 0 from the right, this thing goes up toward infinity. As we approach 0 from the left, what does the function go down toward? Negative infinity. And so that's the definition of vertical asymptote. A place that approaches, but it can't be touched because of the undefined restriction. Okay, something's happening to me. Okay. Does that answer your question a little bit? No?
But I understand what you're saying, though.
Okay, good. You're going to have a lot more time to get familiar with that. Okay, bounded. Is this function bounded? Okay, the thing you do is, this is a little tricky. I'm rewriting this here. This question is a little tricky for boundedness because okay, this is a little tricky. No, the function is not bounded because if you look at this, the thing goes down toward negative infinity here and goes up toward infinity. So there's not a lower or upper bound to it. So the function has no boundedness. All right? Now, the limit as x approaches infinity of f of x, as we go toward infinity here, what does y go to?
Why?
No, we're going this way. What is y getting closer to?
0.
Yeah, 0. See, the thing's getting... Okay, the limit, now we're going to go to the left. Limit as x approaches negative infinity of f of x equals, if we go toward negative infinity, what does y go toward? Also goes to 0, right? And by the way, this is the definition of a horizontal asymptote. It's a number that the function approaches as x approaches either infinity or negative infinity. And so we say there is a horizontal asymptote at y equals 0, yes. Okay, as we go toward positive infinity, this function here kind of flattens out. It's getting smaller and smaller and smaller. And if you go on the table view in your calculator, you're going to see 0.001, 0.00001. The function's going to get smaller and smaller. But is the function value ever going to be 0? No, but the function value approaches 0. So we say the limit as x approaches infinity of f of x equals 0. Okay, well it is. You're going toward negative. You're going toward negative infinity. Now the only difference is you're approaching infinity from the negative side. Okay, you're approaching from the negative side. So this is a negative number getting bigger and bigger and bigger, but never touching zero. Okay, so you're talking about some conceptual leaps here, right? Next, the square root of x. Can we rewrite this as a power of x? So this is going to be x to the what power? X to the power of what? Somebody said it earlier when I said 1 over x. What is it going to be? Okay, you should know this. X to the 1/2, all right? So is this function going to be odd or even? Okay, first we look for symmetry. Do we have rotational symmetry about 0, 0? No. Do we have reflected symmetry about the y-axis? No. So we say that this function is neither odd nor even. And when you think about the power, right, x to the 1/2 power, is 1/2 an even or an odd number? 1/2 is a fraction. Okay, even and odd numbers are for integers. Next, what is our domain? Okay, that'd be greater than or equal to 0, right? I heard somebody say greater than 0, but actually the function domain would be greater than or equal to 0 to infinity. Okay, good. And what is our range going to be of this function? Same as domain? Yeah. Now, the function value is going up more slowly, right? It's kind of flattening out some, but does the thing ever stop going up? No, never does, so still approaches infinity. Next, do we have a vertical asymptote? No. Do we have a horizontal asymptote? No. Do we have boundedness? Yes, where is this function bounded? Yeah, what 0? Well, bounded above or below? Below, right? So that's our lower boundary, so we say bounded below. And now we get to limit as x approaches infinity of f of x. What is our limit as x approaches infinity of f of x? Yeah, it will be infinity. Okay, now for as x approaches negative infinity of f of x, what is that going to be as x approaches negative infinity? Okay? Right, so this function does not actually approach negative infinity. So we say that the limit as x approaches negative infinity does not exist. And I give you a little acronym, DNE, which stands for does not exist. Okay, so kind of caught on, I think. Good job. Okay? Next. This one here. Oh, before we go on here, I want to show you something that most parent functions, in fact, all the ones we've looked at so far, go through this point 1, 1. See that? 1, 1. In fact, all these functions that have parent functions that have x to the power of something will have 1, 1 as part of the points, the values on the function. Here's 1, 1. And your linear function, linear parent function here, 1, 1. Yeah. If you take a transformation of the function, it could be different than that. But parent function will be 1, 1. Okay. Now this one here, is this function going to be odd or even?
Even.
This one is going to be neither. Okay? Why? Well, first of all, it's not x to the power of something, right? And does the thing have rotational symmetry about the origin? No. Does it have reflectional symmetry about the y-axis? No. So that's neither odd nor even. Next, we're going to look at our domain. What is our domain of this function? Our domain is going to be all real numbers. And what is our range going to be?
Yeah. Right.
Greater than 0.
But that was brackets.
Okay. Yeah, why is this a parentheses here instead of a bracket?
What it touches to.
Yeah, this thing is going to get close to 0, but it's never going to actually touch, right?
Why is domain negative?
Because the function can go out negative, greater than negative things. Negative 1,030 quadrillion could be part of the domain. Now the output's going to be very close to 0. It's going to be for all intents and purposes 0. It's actually going to be touching 0 back there underneath, but it's going to, the value's going to get bigger and bigger and bigger, and then the thing's going to be growing exponentially up here like this. That's why. Okay, next, horizontal asymptote, no, vertical asymptote. Is there a vertical asymptote? No. Is it coming to infinity? If we go to the right, is this thing approaching something?
Yes.
Is there a value for y that thing's going to be infinity? See, no matter where we draw a vertical line segment, is this function always going to be able to go through that?
Yeah.
Yes. So there is no vertical asymptote. Because whatever vertical line we draw anywhere in that function, wherever it is, that can be crossed by the function. So that's why there is no vertical asymptote. Is there a horizontal asymptote? What is a horizontal asymptote? Now, you need an equation. Yes, Shelley, thank you. Y equals 0. That is our horizontal asymptote. Very good. Okay, what about boundedness?
Yes.
Where is this function bounded? Function is bounded below. Mr. Hollywood, where are your notes? All right. What is our limit as x approaches infinity of f of x? What is our limit as x approaches negative infinity of f of x?
No, it does go. We do go to negative.
What is the value of the function approaching as we go to the left here? Okay, the thing is approaching 0. That's my question. What do you do?
That's how you do in college. Really? Get two friends.
All right. Next. Here we are, the logarithmic, this is the natural logarithmic function, f of x equals ln x. Is this function going to be odd or even? You say even. Does this thing reflect about the y-axis? No. Does this thing reflect rotationally about this point here? No. This function is neither odd nor even. Next, our domain.
Mr. G, so check yourself. You got an exponent thing that says I can use this check. Does it
That's part of it, if the function reflects, how it reflects. Our domain is going to be 0, infinity. And what is our range going to be here? Yeah, our range is going to be all real numbers. And what is our, do we have a vertical asymptote? Yes. What is our vertical asymptote is x equals 0. Because if we come from the right here, do we actually, does a function actually ever cross this line x equals 0? No, it does not. Okay, approaches, we go down toward negative infinity. Is there a horizontal asymptote? No. Boundedness. Does this function have boundedness? No, it does not, because the range. You look for range for the clue for boundedness, and you see greater negative infinity, less infinity. And finally, limit as x approaches infinity of f of x is, as we go toward infinity, what does the value of the function go toward? Yeah, we'll go toward infinity. Now, again, the function's not going up very fast. It looks kind of like a square root function, doesn't it? But still, eventually, the thing will still increase as we go to the right. Next, the limit as x approaches infinity and negative infinity of f of x. Okay, do we go toward negative infinity here? No, it doesn't. So what is our answer here? Does not exist.
I thought it would be bounded. So on the other side of the door.
Yeah, will not exist on the other side. So the thing is, it's kind of like the square root function in that respect. What looks like one? Okay.
It's bounded, like when you come in, it's like vertically.
Yeah, here there's no boundedness because the thing is coming from negative infinity going up to infinity. Yes.
Is the vertical asymptote from the x equals the x?
No, the vertical asymptote is due to what is being approached as x gets closer and closer to a certain value. Okay, if the thing gets closer to negative infinity or positive infinity, that's vertical asymptote. Well, this is a y value, negative 3. So this thing comes from way down toward above negative infinity, goes up eventually to positive infinity. Okay. Next. This one here, this slide demonstrates that the logarithm of the exponential function are reflections about each other. These are inverse functions of each other. In a few weeks, we're going to go into inverse functions in detail. Next, the sine function. Odd or even?
I mean,
Neither. It's a conspiracy.
No, whoever Monica or whoever said odd was right. Because this thing reflects. You see a rotational reflection? Okay, now, this one here, as far as domain, what's our domain?
right.
Our domain is going to be all real numbers. What about our range?
Negative. Right. Right.
Okay, and what about our vertical asymptote? We have vertical asymptote. No. Do we have a horizontal asymptote? No. Do we have boundedness? Yes.
Yes.
Where do we have boundedness?
Below negative.
Okay, we have below and above.
Okay.
And finally, we have our limit as x approaches infinity of f of x is, what number do we approach as we go toward positive infinity here?
1.
No?
What number does it approach?
What's going to happen to this function going up, the sine function going up and down, up and down? Is it going to continue to go up and down no matter how far we go out? So is this thing ever going to approach a single number? No. So we say that this thing does not exist. And so the horizontal asymptote does not exist. The limit as x approaches a negative infinity of f of x is the same situation. Now, the next function we're going to look at is called the cosine parent function. Very similar. Very similar.
But doesn't touch x.
Now, is this going to be even or odd?
No, it's gonna be odd.
Okay, let's look at this. Does this thing reflect about the y-axis? Yes. So this function is even. Okay, and beyond that, all other characteristics. I'm going to write this down. All other characteristics are the same as for sine of x. Other, I'll call them features, are the same boundedness, domain, range, everything else as f of x equals sine x. Okay? Next, the absolute value function, odd or even. This function is, does this thing reflect about the y-axis? Even. So what is the domain? Domain is going to be exactly what I heard a lot of people say. Boom, all real numbers. And where's our range going to be? Bracket 0, comma, infinity. Not on and beyond is beyond mathematics. Okay, what about our, what's the next? Vertical, do we have vertical asymptote? No. Do we have horizontal asymptote? No. Do we have boundedness?
Yes.
Where's the thing bounded?
Below.
Below. And we have the limit as x approaches infinity of f of x equals, as x approaches infinity, what do we go up to? Infinity or toward infinity. Limit as x approaches negative infinity of f of x is also infinity. And if you and if you go look at your quadratic parent function, you'll see the same characteristic there, right?
Okay. Oh, this even if it's odd, how do you determine you said it has to?
Yeah. Even is reflective symmetry about the y-axis. Okay? And odd is what? Odd is rotational symmetry.
Odd is rotation,
Rotational symmetry, 180 degrees.
and then even flips above the y.
Flips on the y-axis. And there's an algebraic definition too that we can get to at some point. I want you to conceptualize. Okay, the greatest integer function. Okay, this is not either odd nor even. It looks like, actually, technically it might be odd in that it looks like it might reflect rotationally. I don't know. We'll just kind of leave that open here. But one thing this does not have is this doesn't point out that what you do is greatest integer function has little holes at the end of these steps here. Now remember, when you're not going to be able to graph and see a hole, right? And so as soon as you get up to 1, the thing automatically goes up to the next value. And this is really a practical function in that this is what people use to sell gasoline to you, stamps, postage stamps, everything. And yeah, and what is the domain of this function? Yeah, domain is actually going to be all real numbers. Right? Now the range is going to be harder to explain because the range has whole numbers. So here's how we have to write the range. Okay, the range is going to be ... -1, comma, -1, closed, comma, 0, comma, 0, close brackets. And so write this and 1, comma, 1, close brackets, and so on, right? So there's a pattern here. It's each one of these numbers greater than negative infinity to infinity. Integer. In fact, we're going to graph this on our calculator, and this is exactly what I use to put in my calculator to do this. Yeah, just did it. Okay, this one here is our logistic function. Is this one odd or even? It's neither. It looks like it might be odd. Yeah, but the reason it's not odd is because it has rotational symmetry about this 1/2. It doesn't have rotational symmetry about here.
Also got hit right there.
It's got to be rotational about. Now, again, our domain is going to be. What's our domain going to be? All real numbers. Our range is going to be. Actually, it's going to be not bracket. It's going to be 0, greater than 0, less than positive 1. So kind of a strange range. Does this thing have a vertical asymptote or horizontal? Does it have a vertical asymptote? No. Does it have a horizontal asymptote? Yes. Horizontal asymptotes right here at y equals 0 and also at y equals 1. In this case, as you go toward positive infinity, the thing's going to be 1. As you go toward negative infinity, 0. And what is our boundedness? Yeah, below and above. And this one here, limit as x approaches infinity of f of x is what? Equals 1, and limit as x approaches negative infinity of f of x is 0. F of x equals 0. Now your hand is tired out, right? Imagine my hand. I've been doing this all day. Okay. But anyway, that's going to be our 12 basic ones. 3 extra ones here, quickly. This one here is the constant function. And this is x to the power of what? 0. So this odd or even. This is even. What is our domain? domain is all real numbers. Our range is going to be 1, comma 1 closed in brackets. Is this going to be balanced? Does this have a horizontal asymptote? Actually, it does. Horizontal asymptote is y equals 1. Vertical asymptote? No. And does this thing have boundedness? Yes. Below and above. Below, above. Okay, below, above. Okay, the limit as x approaches infinity of f(x) is what? No. What is the limit as x approaches infinity? Is 1. And limit as x approaches negative infinity is also 1. And we have a couple others I want to go over quickly, but we're out of time. But we may look at these tomorrow. Keep your papers. We'll look at these tomorrow.